before I collect. Here we go, guys. Please take a look up here. All right, get settled down, please. All right, yes.
Like 39.
All right, let's take a look. See how 39 is. Okay, here we go. Now, hey, girls. I mean it. All right. Again, find the measure of the exterior angle and the interior angle given the number of sides. Now, again, I tried to go through something yesterday to show you the easiest way to get to the interior angle is not using that formula, but by using the exterior angle. All right? So just to make sure you heard me correctly, 360 degrees is always the total. All right? 360 degrees is always the total. So 360 divided by 7 is equal to the exterior angle. Everybody okay with that? And so then the interior angle would simply be the would be 180 minus whatever that answer was. Now, if you'll notice, n minus 2 times 180 divided by n would also give you the what? Would give you the interior angle. So those two answers should be the same. So I really would like for you to take out your calculator now and just verify that. I want you to physically see it. I want you to do it. Some of you guys are just watching too much. When I tell you something, you should be verifying. Don't trust me. All right? Verify it yourself with your calculators. That's what you have them for. All right? So the first thing we're going to do is we're going to find the exterior angle by doing 360 divided by 7. All right, and that was roughly what?
51.4.
About 51.4 degrees, roughly. Okay? Now I want you to do 180 minus that. And what is that? Okay. Now what I want you to do is I want you to do the interior angle by doing n minus 2 times 180 divided by n. Everybody do that. And hopefully you'll see, wow, that is what? Hopefully the what? Same answer. All right, but don't take my word for it. Don't take my word for it. Emily, is that good now?
Yes.
All right. Anybody else before I take a look at this? I told you guys, it's easy. All right, I agree with you. What?
You do number 17.
All right, let's take a quick look at 17. All right, the interior angles of a quadrilateral always add up to what?
360.
360. Come on. All right, so what do we have? How many x's? 3, 4, 5, 6. It looks like 7x to me. And then it would be what? Minus 4 equals 360. And then solve that for x. That doesn't take any amount of time whatsoever. X is roughly what?
52.
Is it exactly 52?
Yes.
Oh, thank you. X is equal to 52. Now I'm going to read the directions, because a big part of the mistakes in the question on the test is, are you solving for x or are you solving for the angles? In this case, we're looking for what? All the angles. So if x is 52, we can put 52 for angle L equals 52. Angle K is equal to 62. Angle J is equal to what? 150. And angle M, help me. Thank you, is 96. Remember what I said, just keep up day to day, every day. All right, do all the problems. I give you the solutions. You should be able to tell me which ones you don't understand. Anybody having any issues? Good for you. Go. Yes, let's do 26. Here we go. Uh-oh, for some reason I didn't copy down 26.
It's
Do we have to do 26?
Yeah.
Yeah, okay. For some reason I missed it.
It's
I'm listening.
The measure of an interior angle of a regular polygon is given. Find the number.
Well, so what's the interior angle?
60.
All right, now look how simple this is. If the interior angle is 60, the exterior angle is what?
120.
120. 360 divided by 120.
3.
3. So that is a what? Triangle. It's a triangle. Stop. I don't care if he says 1,000. I don't care. All right? Let people talk. Let people make a mistake. All right? I'm tired of it. I told you guys. We're not doing that. I don't care what his answer is. If you got something different, speak up. And let's talk about it. So it's a triangle. Does everybody agree with that? Who asked me about that? Dalton, are you good with that?
Yeah.
You understand what I mean? Do you agree with me? It's much easier to find the exterior angle and then take the 360 and divide it by the exterior angle. So 360 divided by the exterior angle gives you the number of sides, and 360 divided by n gives you the what? Exterior angle. Anybody have any questions? Super simple, super easy. No other questions on this section. All right, that's good news. All right, the next section is just as easy. All right, so let me pause this and. All right, today I think we're going to kind of introduce parallelograms. All right, does anybody want to tell me what they recall about a parallelogram? Tell me.
Isn't it like a shape with two parallel sides?
Shape with two pair of parallel sides, or opposite sides are what? Parallel. All right. So if you were drawing something like this, all right, let's go ahead and demonstrate real quick. All right, here we go. All right, so let's do a parallelogram real quick. And then what I would like to do is I'd kind of like you to tell me some of the properties of a parallelogram. All right, so what I want to do right now is try to construct a parallelogram. All right, so if I say that's a parallelogram. All right, now he said the basic definition of parallelogram is that the opposite sides are what? The opposite sides are parallel. We will get to the opposite sides being equal in a minute. All right, but that's equal to that, or not equal, but parallel for now. And then this is parallel to this. Does everybody agree with that? All right. Now, let's just take a look at this measure right here. Somebody tell me about this measure right here and this measure right there. What's true? They add up to 180. Exactly right. So they are supplementary. All right. They're supplementary. So this angle and this angle are supplementary. All right. Now, be careful with this. All right. What's true about this angle and this angle? Say it again. Yeah, they're supplementary also. All right. So if I were going to mark this angle over here, what would it be congruent to?
The top left angle.
Yeah, or the opposite angle, right? Does everybody agree with that? And so if you're looking at this, all right, those two are supplementary. So it wasn't that hard to figure out that opposite angles of a parallelogram are always what? Yeah, their opposite angles are what? Congruent. Consecutive angles are always what? Supplementary. All right, consecutive angles are supplementary. Opposite angles are congruent. All right, and it doesn't matter how you look at it. All right. Now, I'm going to draw this. Now, again, I always tell kids the hardest part of this is there's so many rules, all right, that you're supposed to memorize. all the different possibilities you have to memorize. And we're going to talk about kites, we're going to talk about trapezoids, squares, rectangles, and you're supposed to memorize everything there is to know. And I always try to tell you, stop memorizing. Look how easy it is to figure that out. All right? Now I'm actually asking you to come on, pay attention up here and stay with me and tell me you understand so far that consecutive sides or consecutive angles are supplementary, which means opposite sides are what? Congruent. Now we're going to prove real quick that opposite sides are congruent. All right? So how do we do that? Let's look over here. If I were to draw this guy from here to here, now, what I'm trying to get you to see is this. Somebody tell me what's true about this angle right here and this angle right here. They are what?
Congruent.
They are congruent because they are alternate interior angles. That is correct. All right, so I know that this angle is congruent to this angle. Now, I want everybody to look at the top triangle. I want everybody to look at the bottom triangle. And I want you to tell me what's true about the top triangle and the bottom triangle. Because side, angle, side. I mean angle, angle, side. Come on now. Everybody's smart enough to do that. Everybody look up on the board. Or I've done it 1,000 times. Those triangles are congruent by angle, angle, side. Because, of course, this green is reflexive. So I have angle. Come on now. All I'm asking you to do is pay attention. Angle, angle, side, and angle, angle, side. So those two triangles are congruent. Now that we established those two triangles are congruent, what can we now say about the opposite sides? They are congruent by what? That is exactly correct. CPCTC. This side is now proven is congruent to that side. And then we can now say that this side over here is congruent to this side over here. Again, same exact reason. So I'm telling you, if something is a parallelogram, I've just said a whole bunch of information. You have to know that the opposite sides are what? Congruent. You have to know that opposite angles are what? Congruent. You also have to know that consecutive angles are what? Now look, even if you don't remember all that, because we are going to go through a whole bunch of shapes, I expect you to be able to reproduce all that information in just a minute. Do you understand what I'm saying? There's no reason to try to write everything down and try to memorize all those rules. I think it's much easier to just draw a parallelogram and figure it out for yourself what's true about the parallelogram. But obviously we're going to do it so much that the rules you should recognize rather quickly. So if I tell you something is a parallelogram, all of these properties are true. Anybody have any questions with that? Does everybody see how really simple that is? All right? Just because you understand proofs a little bit better. All right? Now, obviously, we could prove all those, but we just did that. We just didn't write it down. All right? Is everybody comfortable with that? All right, I do think it's easy. And I'm serious now. Part of the reason I'm fussing at some of you guys so early is because I care about your grade. And some of you guys made B's. All right, and you're not B students. All right? So please, get with the program now. Make sure you go with me section by section. Do all the problems. And then come with questions the next day. I'm providing you with solutions. Go home, do the problems. Come back and tell me the ones you can't do. All right, there's no reason not to do well. All right? You have one more chance now to get your grade up to an A. All right, and I already promised you we don't have as much work this semester or this quarter. All right, so I think sometimes it's easier and sometimes it's harder, especially if you make a mistake. All right, so please keep up and pay attention. All right, now let's finish this homework up. Okay, back to the top. All right, now that we've proven everything. Now it's just a matter of Let's go through it. Number 1. All right? I don't really like those, so let's just go to number 2. All right, here we go. Find the value of each variable in the parallelogram. So, how do I solve for x? Someone be brave. Tell me real quick. Go. Beautiful. 2x minus 1 equals 75. And then I'm expecting you guys just to tell me x is equal to what?
37.
30 what?
38.
I think it's 38.
Oh, nice.
Doesn't matter. No one cares. I think it's x equals 38. Anybody have any issues with that? Now, you could have also written it as 105 plus 2x minus 1 equals 180 also. But it's always easy to do opposite angles are congruent. Now, it says find the value of x. It doesn't say find the value of the missing angles. All right, so you got to be careful on the test. That's what's going to happen. Number 3, what's the equation? Someone else. Go.
Y minus 4 equals 11.
Y minus 4 equals 11. So tell me.
Y equals 15.
Y equals 15. All right, now we're going to ask someone different every time to give me some help. So once you say something, let someone else say something. All right, anybody have any questions with number 3? Yes, something I forgot to mention. What do you think is true about the diagonals? If you had to guess. What did you think? Say it again. Yes. So what am I at? What's the word I'm looking for? What do the diagonals do? What do they do to each other?
Bisect each
Yes, they bisect each other. All right. The diagonals of a parallelogram bisect each other. All right. Are the diagonals congruent? Everybody look up and tell me if the diagonals are congruent. Look up there. Tell me if they're congruent. Now think of it this way. Watch, guys. Look right here. The more my parallelogram tips to one side, one diagonal becomes what? Greater, and the other one becomes
Smaller.
yes. If they're at rectangles or if they're at right angles, what's true about the diagonals now? They're congruent. But as soon as you tilt, one diagonal gets what? Larger, and one gets smaller. Now, again, that's why I'm telling you, listen to me, please. Try to hear me. I don't have all this memorized. Every time I do a unit, I just relearn all the rules because it's much easier for me to relearn all the rules than it is for me to memorize everything. Does everybody understand that? All right, so if I look at something like that, I can visualize that those diagonals are not congruent. Does everybody agree? All right, now, it's a good guess to say they are congruent. But hopefully you understand as we tilt them, all right, one's getting smaller and one's getting bigger. So that must be something else is true. All right, and that something else is that the diagonals of a parallelogram always bisect each other. They bisect each other, which means they cut each other in what? Half. All right? So, whoever said that was correct. What is it? Tell me again. A minus 7 equals 2. And what else did you say? 2b minus 6 equals 10. So, obviously, we don't have to do much work here. A is what? And B is 8. Come on, guys. Anybody have any questions with that? All right. So here we go over here. So someone else is speaking up now. Go. Loud and proud. I can't hear you. And okay, so B is equal to obviously what? Better answer. Four. All right, and then everybody should be able to do the mental math here and tell me W is what? Everybody happy with W being 5? Everybody okay with that? Any issues? Any issues? I agree, pretty easy. All right, here we go. Determine the coordinates of the intersection of the diagonals. All right, so let's go down to the bottom. I'm going to put this up. All right, sorry, you guys should really have graph paper, but just watch me. I'll pass out some graph paper, hopefully. That's why I kind of like your iPads, but... All right, here we go. All right, so let's see what we got here. All right, determine the coordinates of the intersection of the diagonals. We'll just do it once, then you'll be able to tell me. All right, what do you think the diagonals are? If they bisect each other. So I'm asking you a question. If the diagonals bisect each other, then what is the intersection? Come on now, you got to think about what I just said. Please try to think about what I just said. The diagonals bisect each other. So that point is called the what? It's a point of intersection. But what is it called? It has a specific name. If it's bisected. All right? I'm just going to give it away. Here, look. This right here, right? I'm going to bisect that. All right? Now, if I bisect it, is that a bisector? Yes, because I said it was. But what is it bisecting? That's telling you that this is congruent to this. Does everybody hear me? Everybody got that? Did I bisect this?
No.
I didn't say that. I said that line, that highlighted line, is the bisector of the other line. So my question to you is, this has a meaning. What is that point right there called? What? Yes, come on, midpoint. Very good. Thank you very much. That is the midpoint. Does everybody hear me? So I'm going to draw this out. And because you don't have graph paper, you can just kind of watch. And then you can kind of see, wow, that makes sense. All right, so let's plot the points. -4, 6. 1, 2, 3, 4, 1, 2. Well, that's not very good. All right, here we go. -4, 6. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6 is here somewhere. 5, 6. 1, 2, 3, 4, 5, 6. 4, -2. And -5, -2. All right, so let's look at this real quick. So if I'm drawing this parallelogram, oh, that's obviously not right. -4, 6. Did I do C wrong? 1, 2, 3, 4. -2. Oh, no, D is wrong. -5. No.
No, you did
6 for D.
For D, you did
6. You did -6.
1, 2, 3, 4. -4. 1, 2, 3, 4, 5, 6. So that's A, right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. That's B. 1, 2, 3, 4, -2. Thank you, guys. 1, 2, 3, 4, 5, -2. Should be right there. Thank you. All right, so here we go. All right, so that's our parallelogram. All right, now let's just see if you can see what I'm talking about. If I draw this from here to here, and I draw from here to here, now we can clearly see what's the answer.
0, 2.
0, 2, right? So now, what I'm telling you now, and please listen to what I'm saying, because again, I think it's so helpful when you sit down to take this test. There are hundreds of rules. Is it possible to memorize all the rules? It's not possible. It's much better to understand what I'm saying. If the diagonals bisect each other, that means this is equal to this. correct? And that means this is equal to this. Does everybody agree with that? Which means this is the midpoint, right? Now, you agree that the midpoint is going to be the same. So it doesn't matter what diagonal you use, you just have to do the midpoint of either one, right? So we want to take a look at AC. If I find the midpoint of AC, remember, midpoint is an average. So -4 plus 4 is what? 0 divided by 2. Good job, guys. 6 plus -2 divided by 2. There you have it. All right. Now, if I do B and C, it's probably going to be what? Same answer. All right. Do you understand that? Because the diagonals bisect each other, that means the midpoint is the same for both diagonals. Do you agree? All right. So whenever somebody asks you what the intersection is, it's just the what? Midpoint. That's all it is. All right. That's all it is. All right. Now let's go back. See if there's anything harder, hopefully. All right. Question number 7. Now again, I don't really care about indirect proofs. We only write proofs. All right, 2-column proofs. But wait a minute, which ones did I tell you to do? Number 7. Yes. So let's give it a shot. Given now that is obviously the symbol for what? Parallelogram. Does everybody agree with that? Now look, guys. Honestly, this proof is super easy. All right, so just watch with me. I'm not going to make you write this one out. All right, I think I'm going to make you write out number 8. All right, but not number 7. All right, so it says parallelogram ABCD is a parallelogram, and then angle A is a right angle. So if angle A is a right angle, then what's true about angle C? It's a right angle, correct? Because it's what? Supplementary, right? So angle C has to be a right angle, all right? And what about angle D? Has to be a right angle because opposite angles are what? Congruent, or consecutive angles are supplementary. All right, I'm not really going to do that. All right, that was too easy. All right, does everybody agree with that? All right. So if there's one right angle in a parallelogram, then all 3 angles are parallelogram, which actually makes the parallelogram a what? The parallelogram becomes a rectangle. Could be a square. Doesn't have to be a square. Could be a rectangle. All right. Now let's look at number 8. All right. So let's go ahead and do number 8 as a 2-column proof here. Again, I'm just going to copy this, and then I think we should be in good shape. I'm just going to go ahead and put it here. I don't think this is a big deal. All right, here are my statements. And here are my reasons. All right. Number 1. All right, here we go. Given. All right. Now I'm trying to prove that angle A is congruent to angle F. So someone give it a shot. Number 2. Come on, someone be brave here. Good, Michael. What?
BC is congruent to CG.
Say it again.
BC is congruent to CG.
Why is that? Nope, somebody else. Tell me something else. Good try. Good try. What do you think?
BC. I guess you could do BC. CG on
Tell me.
A's
Definitely.
because
Very, very, very important.
they're both.
Hold on 1 second. I'll let you finish in a second. Now, I just want to tell you guys are talking about sides. if it were me and they were asking me about angles, the first thing I wouldn't do is jump to the sides. I would try to relate the what? I would try to relate the angles, okay? So anytime they're asking about angles, let's start with the angles. That's why that was a good job. So we would say angle A is congruent to angle C, and we would just simply say opposite side or opposite angles of a parallelogram are congruent. All right, we know that. Opposite angles of a parallelogram. Thank you, guys. Opposite angles of a parallelogram are congruent. All right, so now let's mark the figure. So angle A is congruent to angle C. Now, I technically shouldn't say angle C. Let's go ahead and make that what, guys?
BCH.
BCH. Angle BCH. Thank you. All right. So that's a good start. Now, someone else jump in here. Someone else. Catalina, what? Good. Same reason. All right. Do we agree with that? Same reason? So we're going to say angle F is congruent to angle DCG. All right. We can just combine that with angle 2 or with step 2. Does everybody go good with that? Everybody all right with that? Those are still opposite angles of a parallelogram. Someone else, be brave. Be brave. Good. Angle. Well, now look, here's what I want you to do right now. So I want you to, because you raised your hand, I want you to look at this right here. Now, we're trying to prove. Okay, let me see something now for a second. So what I want to do is, I've proven that this. Let me highlight these. All right. I've proven that these two things are equal. So what? Close. We can't say that quite yet. Yeah, they're vertical. All right, we're getting there. All right. Come on now, I like that. All right, so here we go. Step 3. Angle BCH is congruent to angle DCG. And those are vertical angle theorem. Now, like I said, if your answer wasn't correct, it doesn't matter. You gave it a shot. All right? So now we know that I can convert the 2 marks into a what? Single mark. Does everybody agree with that? So let me go ahead and change this. This now is a single mark. That's a single mark. Now, how do we finish it up? Tell me. Exactly right. Number 4. Now we can say angle A is congruent to angle F by what? Yeah, that's a big substitution. Substitution. Now that's the kind of proof that I think is important. All right? Double check me on that. They ask about angles, so I didn't start with the sides. I tried to relate the what? The angles to each other. All right, anybody have any questions? I don't think that's too bad. All right, now let me just scroll down because I don't want to give you anything too hard here. I think you can do 23 and 24. Find the coordinates of the intersection. That's easy. That's easy. All right, honestly, I think you can do everything. All right, now look, do me a favor. Try the proofs. If something doesn't happen or you don't see it, then you kind of look to the solutions to guide you through. But you should try it first. Don't just go to the solution, say, I can't do it, so I'm just going to copy it down. Don't do that. All right, it's not helpful. All right, anybody have any questions? All right, I think you can do 23 and 24. I don't think that's a big deal. And then the other one's very simple if you listen to all the rules for a parallelogram. All right, I'm pretty happy with today, guys. Good job. All right, stay busy. All right, when I call your name, come get your homework, okay?